Let us solve this signal flow graph problem. Now I've written the nodes, which is x1, x2, x3, x4, x5, x6 and x7 here. These are the loops. There are 4 loops and there are 2 different forward paths. Here x1, x2, x3, x4 is a forward path and x1, 5, 6, 4 and 7 is another forward path. This is a loop. This is another loop. This is another loop. This is another loop. Wherein first step is to find the forward path. As I've written here, let me consider T1 is the first forward path. Then for T1 it's x1, x2, x3 and x4. As I've written here, x1 has unity as its gain and x2 has 1 by r1 as its gain, x3 has 2r1 and x4 as 1 by r0 and x7 has 1 as its gain. When you multiply all this, you get 2 by r0, which is the first forward path's gain. Now the second forward path is x1, x5, x6, x4. Here, when you multiply this second forward path, gain is 1 by r0. The next step is to find the loop gains. Now let me consider this as first loop, second, third and fourth. For the loop gains, you have to multiply the gains here. For the first loop, it's 2r1 into minus 1 by r1 and it results in minus 2. For the second loop, it's 1 by r0 into minus 2 by r1 and it results in minus 2 by r0 into r1. The third loop is minus 1 by r0 into r1 and it results in minus r1 by r0. And the fourth loop is r1 into minus 1 by r1. The fourth loop gain is minus. The next step is to find the 2 non-touching loops. Before finding it, let's know what are 2 non-touching loops. This is L1, L2, L3 and L4 which I've considered. Now according to me, L1 and L3 are non-touching, L2 and L4 are non-touching, and again L4 and L1 are non-touching. So such non-touching loops are to be multiplied and their gains have to be added in the Mason's gain formula. As I've told you here, L1 and L4 are non-touching. The L1's gain is minus 2 and L4's gain is minus 1. Here the resulting gain of L1 into L4 is just 2. And here L2 and L4 are non-touching. This loop and this loop are non-touching. And then the resulting gain is 2 by r0 into r1. And again L3 and L1 are non-touching loop. The resulting gain is 2 into r1 by r0. After finding 2 non-touching loops, then you have to find if there are any 3 non-touching loops. As you can see here, there are no 3 non-touching loops, hence it is 0. The next step is to find what is Mason's gain formula. The transfer function according to Mason's gain formula is summation of delta k into tk divided by delta. K is number of forward paths. Delta is equal to 1 minus the loops which you have found, including the self loops for any problem in case. Then the non-touching loops, the 2 non-touching loops minus the sum of 3 non-touching loops. As we have found here, this problem here, the loops are L1, L2, L3, L4. The non-touching loops are L1 into L4 plus L2 into L4, then L3 into L1. There are no 3 non-touching loops in our problem. Then we substitute their gain values, and delta 1 is nothing but loops which are touching the first forward path. Here, for the first forward path, that is x1, x2, x3, x4, the loop which is non-touching to this first forward path is L4. So where delta 1 is equal to 1 minus L4. The resulting delta 1 is equal to 2. And again, delta 2, that is this forward path is non-touching with this particular loop which we have considered to L1. So the gain of this L1 is minus 2 and delta 2 becomes 3. In our problem we have only two forward paths, so it's just delta 1 and delta 2. And the transfer function here, as I've already told, we have to substitute in the Mason's gain formula. According to Mason's gain formula, it is delta 1 into T1 plus delta 2 into T2 divided by delta. As we have only two forward paths, we take only delta 1 T1 plus delta 2 T2 divided by delta. As we've already substituted what is delta, delta 1, delta T1 and delta 2 T2, we can substitute those values and finally write the transfer function here. As I've written here, this is the transfer function of the signal flow graph.